So this is a video of our half-turn stairs with a landing midway. So I'm doing the example we did in class for the first example. So I'm going to go ahead and just kind of write down the given information. So we were given a total rise of 9 feet. Upper construction was 12 inches. Headroom was 6'8". And then there was a landing which was 4 foot by 8'6". Okay, so basically what we're doing here is half-turn stairs or U-shaped stairs. So basically we have a landing, which is like it's written down here, 4 feet. So it's 4 feet in this direction. So 48 inches there. And then across the back here we have 8'6". Okay, so the stairs are basically coming off of two sides, right? So it's a U-shaped or a half turn. Right? So the stairs are coming off there, and they're also coming off here. I'll kind of stop there on the drawing until we get some actual numbers there, but I usually have this as my up. So I'm coming from the first floor, going up to a landing, from there up to the second floor. So that's a half-turn stairs or U-shaped stairs. So the way we're going to tackle this one here is we're going to take the total riser rate away and then divide by 2, which is actually going to give us our landing height. Right, so our landing height is going to be the first thing that we're going to do here. So we're actually going to take the total rise and then we're going to divide that by 2. So different to what we did with the straight run. Now we're actually going to break that up into, we could have did the straight run this way as well. Right, whenever you have a landing midway, you could do this, so that is an option. So our total rise is basically 108 inches. 108 inches. Headroom is 80 inches. And I think we have everything there that we need to do the math. So we're going to take that 108 and we're going to divide that by 2. So basically 4'6", or 54 inches here. Right, so 4'6", gets us right in the middle there. Okay. Second thing we're going to do there is kind of now do the calculations based off of that being 54 inches. So we're kind of doing individual flights. So this is a flight of stairs here, and then we have another flight of stairs here. So we're kind of breaking it up. Instead of using the total rise of the entire staircase, I'm only using to the landing height. So I'm going to get the calculations based off of the flight. So number of risers in a flight, right? So the bottom section, just the bottom section. So I'm going to use the total rise at that location, which is basically my landing height, the 54 inches, and I'm going to divide that by 7 to determine the number of risers. So I'm going to take the 54 inches and I'm going to divide by 7. Okay, so grab my calculator here. So 54 divided by 7 gives me 7.71, which that's the number of risers, right? So I don't really normally write all that stuff, right? We'll just keep the decimals. That's the number of risers, and then see if that's actually going to work. Okay. So step 3 there is getting the unit rise for a flight. We're not going to write down flight every time, but that's kind of what we're doing there for the flight. So I'm going to take the total rise, I'm going to divide that by the number of risers in the flight. Okay, so total rise for the flight is 54 inches divided by 7. It's going to give us the number that's already in the calculator. So we'll just turn the light on here. I think the light is on. Can we see those numbers? So I'm going to write that down, 7.7142 inches. So let's put that in fraction there now. So I write down the 7, so I'll subtract the 7 out of my calculator. Let's put fractions of it in, so I'll multiply that by 16. That gives me 11/16. So 7 and 11/16, okay? Then what I basically do is get my unit run, right? So unit run, we're going to use the 17.5 inch sum rule. So 17.5 minus my 7 and 11/16 is going to give me 9 something, so it's not actually going to meet code. So we're going to have to backtrack and change a few things here. Let's just get the number there. So 17.5 minus, what's 11/16 here? Let's just write that down first. So 11 divided by 16 is 6875. So now I can go 17.5 minus 7.6875. So that gives me 9.8125, which is 9 and 13/16, I believe. I'll just double check that. Yeah, 9 and 13/16. So code has to be 10 here, so that won't work. It doesn't meet code. So that won't work, right? So we got to go back up here and change a few things. So we got the number of risers. 7 is not going to work, so we kind of want to make this number here a little bit smaller. So to make that a little bit smaller, I'm going to increase this, change that to 8. So I'm just going to circle that. So this is no longer going to work, right? So I'm going to divide by 8 now, because that's not going to work. So just get my answer here. Rather than rewrite it all out, so I'm going to go 54 divided by 8 gives me 6.75 inches, which is 6 3/4. Okay? So again, that's not going to work. So I'm basically just scratching that off, plugging in the 6 3/4 there, which is then going to give us a new number of 17.5 minus 6.75. That gives us 10.75. So 10 3/4. So maybe I'll just circle the answers I want. Right, so the first time through we had 7 risers, which gave us a unit rise of 7 11/16. When we used the 17.5 inch thumb rule, we ended up with 9 and 13/16, which doesn't work for code. So we had to backtrack, change the number of risers to 8, which then gave us a unit rise of 6 3/4. Using the 17.5 inch thumb rule gives us a unit run of 10 3/4. So now that's work. We're meeting code there. Right? That's a little low, but it'll work. It's close enough to what we need. Okay. So now what we kind of could do is go ahead and finish this drawing off. So there's basically, if we kind of writing that down here, there's 8 risers, which is 7 runs per flight. Okay. So if I were to go ahead and draw this out, I actually need 7 runs there. So there's 1, 2, 3, 4, there's 5, 6, and then 7. So my stairs are going up that direction. Sometimes they'll write 8 risers, okay? So I'd go up, come back around, so I'd also have 8 risers or 7 runs. So I'm at 4, 5, 6, 7, okay? So I have 7 runs, 8 rises. 7 runs, 8 rises. Go ahead and put that there as also being 48 inches. Okay. So now we can continue, right? We can continue with our problem there. We're happy with those numbers. So step 5 there is getting the number of rises / runs in the opening. So something that we've done several times, right? We need that to get our stairwell opening. So we'll get that out of the way. So we take the headroom for that plus the upper construction, and then we divide that by the unit rise. So our headroom was given as 80 plus, it's a little fuzzy here. Just going to see if I can get this automatic focus there. It's a little bit better. So 80 plus the 12, right? 80 inches plus 12 inches. And we divide that by the unit rise. That's now 6 3/4. So 6.75, okay? So basically 92 divided by 6.75. So we end up with 13.6296. So we decided in class to go 4 decimals here, not 2. A lot of people are going 2 with assignments, but let's go 4. It doesn't change it a whole lot, but we should stick to what we decided. So basically we have that now, which is how many runs are in the opening. Right? We started off by calculating the number of rises in the opening by taking vertical distance divided by vertical distance, but it then turns into runs in the opening. So we kind of looked at that way back when there, but whenever you have your stairwell opening, there's a triangle that's formed, and this side here is basically your headroom plus your upper construction from that point to that point, and then from there to there is our stairwell opening. So the first part of this formula is taking this number and then dividing it by the unit rise, which then tells us how many vertical parts we have in the stairwell opening. Once we know how many parts we have here, so in this case we actually have 13.6296 parts here, that means we also have 13.6296 parts in that direction. It's just that they're larger. And so I showed a diagram like this in the class. That's what that formula is doing. Okay, so whether it's a straight run with a landing, a quarter turned stairs with a landing, or a U-shaped stairs with a landing, we're using that formula. Okay, 6 here, we're going to go ahead and get the stairwell opening above the landing. That's the easiest one. So again, we're going to use that diagram. Okay, so this here is actually the stairwell opening above the landing, right? That's our landing. This is the upper section. So that's actually going to be the hole. It's going to go from here, here, back around, and probably stop somewhere over here. So it's kind of a little bit of a check in that stairwell. So for now, we want to find this distance. So we already have those numbers put in place. The drawing basically gives us our answer. More people should be using the drawing. I noticed that they're not, but anyways. So if I were to kind of break this apart into parts, I want to calculate the distance basically from here to here. Right? So from that point to that point. Well, that's how many runs I have. Each run is 10 3/4. So I've got 1, 2, 3, 4, 5, 6, 7 runs there. Right? So what you do is you take the number of runs above the landing and we multiply by the unit run, and then we add on the landing, right, because we need to add the landing, and then we add on 3. So again, that formula is not really necessary if we kind of look at what we have here. We've got 1, 2, 3, 4, 5, 6, 7 runs, so I'll write down 7 runs. Each of those is 10 3/4, right, 10 3/4. So I multiply that by 10 3/4. That gives me, that in brackets there, gives me the distance from here to here. From there I got to add on 48 inches, which is the landing. And then I have to add on 3 inches that we didn't really account for. But that's for possibly shimming here, for a riser hiding the floor system, the nosing, that kind of a thing, drywall in place there. So that's what the 3 inches is for. It's a little extra, but it's pretty well standard. Okay? So if we go ahead now and we go 7 times 10.75, and then add on the 48, and then add on the 3, we end up with 126.25 inches, which is basically 10 foot, 6 1/4, right? So I'll just kind of do the processor. So if I divide that by 12, there's my 10 feet. I now subtract the 10 out of the calculator, multiply by 12 because I want to find out how many inches there's there. So there's 6 whole inches, subtracting inches to be left with fractions of an inch. I want to find out what that is over 16, so I multiply by 16. That tells me my numerator, so 4/16, which is reduced to 1/4. So 10 foot, 6 1/4. That's what we have right here. 10 foot, 6 1/4 is the distance from there all the way to there with our 3 inch allowance. Okay? So that's basically done there. And the last thing we need there, or as far as I'm going to go anyways, is getting the stairwell opening below the landing. That's where the number of riser runs in the opening come into play. Okay? So basically what we have to look at is how many did we use. That's one way you could do it. How many treads did you use? I'm going to count these out. There's 1, 2, 3, 4, 5, 6, 7. This is a large tread, so that's 8. And then we have 9, 10. So how many do we have total right there? We have 13.6296 runs in the opening. So if I keep on going there, I've got 11, I've got 12, I've got 13, and then it's 0.62. So it's going to end somewhere about there. That's where the stairwell will end. So if I were to take a different color pen here, the stairwell will actually go like this, along that line. It'll then check over to here, and then back around. That's the size of the hole in the actual floor when we're framing it. So it's cut off at that location. It doesn't have to go all the way through. That could be potentially for a little nook there, for a bench. It could be a closet. We could use that space, right? So some people might decide to make that perfectly rectangular, and others might decide to check that in. So the key is knowing that there's 13.6296 runs in the opening, so it starts from here. So we have 7 to that location, there's 8, and then there's a few more on this side. So that kind of helps us do the math, right? So if we're a visual person, we can then just determine what is the distance from here to here. So I could count those out, right? I could have a fancy formula, but I can also just follow this drawing. So if I actually went 1, 2, 3, 4, 5, and that's the decimal, right? So if it's actually 5 there, 0.6296 parts, multiplied by the size of one tread, which is 10.75, and that will give me the distance from there to there. Then I'd add on 48, and then I would add on 3 inches. And that's basically my formula. I don't need a formula. So if I'm going to write down a formula coming kind of out of a textbook, what you're going to do is you're going to take the number of runs in the opening, and you're going to subtract number of runs used in upper stairwell opening. Okay? So lots of words there. And then from there, we're going to take that number and we're going to multiply it by the unit run. Put another set of brackets on that. And then we're going to add on the landing and then add on 3. So that's basically the formula there. So if I kind of write all that down, number of runs in the opening was 13.6296. How many runs did I use? Well, I used 7 here plus the landing, so 8, so I'm taking away 8. And then from there, throw some brackets on that. I multiply that by my 10.75, 10 3/4. Put brackets on that, and then I'll add on the landing. The landing was 48, and then add on 3. So basically this number here ends up being 5.6296 runs multiplied by 10.75 plus 48. So that's following a formula, which I don't really like. If I come over here, you see how quickly I see that was 5. 1, 2, 3, 4, 5. 0.6296, because there's part of another tread being used there as well. So a lot of people screw up here and they have trouble with that 8. Right? What that 8 means is how many were used. I used 7 runs above the landing, and the landing is also another tread. So some of the assignments for the quarter turn, I noticed that we're having issues with that. The drawing eliminates that error, right? So you basically have to count out how many runs are used in the opening. It starts here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.62, because that's what we calculated. And then from there, we're kind of doing a subtraction with the drawing. That tells us that we have 1, 2, 3, 4, 5.6296 treads in this opening, right? The opening that we're trying to determine is this distance from here to here. So from here to here, there's 5.6296 runs. Each of those runs are 10.75. So if I go 5.6296 times 10.75, that gives me the distance from here to here. Then I add on 48. So there's the formula, and then I add on 3. So that's kind of exactly what we have down here, right? Is exactly what we have there. That's a visual of it. So now I feel confident that I got the right numbers, okay? Let's just plug those numbers in now. So if I go 5.6296 times 10.75, press equals, add on the 48 plus 3. So I end up with 111.5 5182. Okay? Which is 111, so I'll get rid of the 111 there. To find the fraction, so times that by 16. So that's 8/16, so that's basically a half. So 111, so 111 divided by 12, so 9 foot. There'd be 3 inches left over, and then a half, right? So 9 foot. 3.5 would be the distance on that side there. So 9 foot, 3.5. So now I know that distance, I know that distance, I know that distance. This here would basically be more than likely half, or if we know the stair width, that was kind of given to us, we'd subtract 40 inches, more than likely, somewhere in that range off of the 8'6", and that would give us that distance there, okay? It could be in the middle, but if it's in the middle, the stairs might not fit nice and clean. Normally this is like a open stringer that might get mitered with a railing, and that might be the same thing over here. So this might actually be open space down to the lower level, or they could be closer together, almost making contact, just having one railing down the center, like a small little wall down the middle. That's a possibility as well, but that's your basic shape there. So we have this distance, which gives us that shape. We have this distance, and we have that distance going across, okay? So that's basically it. There's still the angle to get. I think on the assignment there, we're looking for the angle there, but that's pretty straightforward. We've done that several times.